Before you view this video, please make sure that your homework is uploaded to the Google Classroom. All right, determine the points of inflection and discuss the concavity of the graph. I'm going to go over this homework assignment. Okay. All right, so, I don't know why it's doing blurriness. Okay. So I'm going to take this and I want the points of inflection and concavity. So that means I'm going to do double prime. So f prime of x equals 4x cubed minus 12x squared. F double prime of x equals 12x squared minus 24x. Now there's nowhere that it doesn't exist, so I'm just going to straight hit with 0. And then I'm going to take out a 12x. So then I get x minus 2. So x equals 0 or x equals 2. Okay, and since those are fine for the domain, then I know that those are zeros. Okay, so next I am going to put them on a number line. And then I am going to, so then I'm going to put 0 and 2. And then I'm going to plug in points into f double prime. So right here is where I'm going to plug it in. Make sure that if you do plug in things that you plug it in where before you like divide anything, because 0 can make things happen, like go away. But I'm plugging it in before like anything was solved. Okay? All right, so -1. So that's negative times negative, which is positive. 1 is positive times negative is negative. And then 3 is positive times positive, which is positive. So then this is concave up, concave down, concave up. Okay? All right, now it says the points of inflection. So then that would be, so inflection points would be f of 0, which plug it way back here would be 0. And then f of 2 would be 2 to the 4th minus 4 times 2 cubed. So then that's 8 times 2 minus 4, which is -2, so -16. What I did there was I factored out a 2 cubed, which is 8, and that left me with a 2 minus 4. And that just helped me do my multiplication faster than trying to do 2 to the 4th minus 4 times 2 cubed in my head without a calculator. Okay, and because it didn't say to use a calculator in this problem. See? Nothing about check the graph and get the calculator or anything. All right, and so those are the inflection points. And then concave up. X is from -infinity to 0, union 2 to infinity. Concave down, x is in 0 to 2. Okay, there's your homework. All right, now this page, actually, I was kind of going through it on my own, so it's already written the answers of it, but draw 2 graphs that are concave up, one increasing and one decreasing. There's concave up, and there's concave up, increasing, decreasing. Is it possible to draw a graph that is concave up and has a relative maximum? Yes, it is, but it's got to look like this, where the derivative doesn't exist. Okay, you can't put them together. If you move this over to this side, no, it would always be concave up. Okay. All right, draw 2 graphs that are concave down, increasing and decreasing. Is it possible to draw concave down as relative minimum? Yes, it is. You got to make the bird. Okay. All right, so we can conclude that if the slope of the graph is 0, so these are does not exist, remember? So right here, and here, these are f prime does not exist. Okay? So if the slope is 0, that's a hump, right? Not a sharp point, and concave up. Then you've got to have a minimum, because the only way to put them together is to like rearrange these to make a parabola. So basically what you normally want to do. Okay, and if it's 0 and concave down, then it has to be a maximum, because if you switch them the other way, then you get that point. Okay? All right, draw a graph that has a relative maximum or minimum, doesn't matter which one, but does not have any concavity. Well, I chose the absolute value one. Okay, you could also draw like a flat line, that would work. That's an absolute, and it has a relative maximum everywhere. Okay, that does not have any concavity. It's not curved at all. All right, and what can we say about the slope? Now, this one you didn't have to do for homework, just like you didn't have to do these, so hopefully you filled those in as we were going. Okay, what can this say about the slope of the graph? Well, it's got to be constant. Okay. All right, so the second derivative test. The second derivative test says that the function, if the function is f prime of c is 0, so the first derivative, I fixed that because you couldn't really tell it was a single prime. So f prime of c is 0, and the second derivative exists. If the second derivative is positive, okay, well, that would be concave up. So just think of your usual one if you wanted for the second derivative test. Then it's a minimum. If the second derivative is concave down, it's a maximum. So just the easiest way to think about this is think parabolas. That'll help you because they love the second derivative test on the exam. So, all right, find the relative extrema. Now, I didn't put the things, but let's add using the second derivative test. Okay. All right. So first we take the first derivative and set it equal to 0. Okay. Then you take the second derivative and you plug that c into it. And if it comes out positive, it's a min. So opposite of what you say, positive is a min, negative is a max. Okay. So we're going to need the first and second derivatives. All right. So let's do the first derivative. That's going to be f prime of x is negative 15x to the fourth plus 15x squared. Okay. All right, now we're going to set that equal to 0 because that's what it says. All right. So this is not going to work. Second derivative test does not work if you have places where your derivative does not exist. It only works if your domain is like all real numbers. Okay. All right, so we're going to set that equal to 0, and then I'm going to factor out a negative 15x squared, and I get x squared minus 1. So negative 15x squared, x plus 1, x minus 1. So x equals 0, x equals negative 1, x equals 1. Okay? All right, now instead of putting those on a number line and testing around them, I take those and plug them into the second derivative. And if it comes out positive, it is a min, and if it comes out negative, it's a max. I've already told you that I'm not a fan of the second derivative test. I think it's just something extra to memorize when you already know how to do this by just putting them on a number line and testing around them. Okay, plus you're going to find out a lot more about the graph if you just test around them, because you need to know increasing and decreasing a lot of times. But if it straight up just says find the relative extrema, second derivative test is useful. And we are going to put it on your memorization sheet because, like I said, the AP exam likes the second derivative test. Okay, so now I'm going to do f double prime of x. So then that's what? Negative 60 x cubed plus 30 x. Okay. And then now I'm going to take each one of these and plug them in. So f double prime of 0 is 0. See, so it's inconclusive already, right? Because you have to know what, like, that didn't help. It would have to come out positive or negative. If it comes out 0, it's inconclusive. So I'm still going to have to test around it. Okay? Which is f prime. So pick something that's like negative 0.5. You don't want to pick negative 1. That's one of these, right? And then 0.5. So plug it all the way back into prime right there. So that's going to be negative times positive times negative. Yes, times negative. So this is positive. Now plug in 0.5. That's negative times positive times negative. So that's positive. So that's not an extrema. That's a shoulder. Okay? Did I do that right? Positive. Yeah. Okay. All right. Now f double prime of negative 1. So what I'm saying is, like, you plug these in, you'll see for this one. Okay, so let's plug it in. So we plug in f double prime, negative 1. So that's going to be negative 60 times negative 1, so that'd be 60 minus 30, which is positive. So that is a relative min. Because it's concave up, so it's a relative min. But it says find the relative extrema, so you still have to do f of negative 1. All the way back there. There we go. So you get negative 3 times negative 1, which is 3, minus 5, which is negative 2. All right, now f double prime of 1. So double prime, so that's negative 60 plus 30, which is negative. Okay, so then negative is concave down. Parabola, think parabola, that's going to be a max. Okay, so that's a relative max at f of 1. Plug that back into 1. That's negative 3 plus 5, which is 2. And this one's a shoulder. No, sorry, it's not a shoulder. It's just not. Oh, yeah, because it's prime. I did prime and it's up and then up. So that is a shoulder because that's increasing to increasing. So it is. But do you see how I had to do the first derivative test anyway on this one? Because when I plugged it in, it didn't come out positive or negative. So it was the second derivative test was inconclusive. But where this is useful is if you already found the second derivative, like you had to do concavity or whatever, or you're given hints about it and you're told the second derivative is positive and the first derivative is 0, then you know it's a min. Okay? That's usually where it's going to come up, is where they're just giving you clues about the function. All right. This page was crossed off. I think I crossed it off of everybody's, but anyway, we're not doing that page. That's limits, and we already did that. So now we are on to 4.6. Well, sorry. Yeah, but anyway, it's a summary of curve sketching. So these are all the things that you know how to do now. X and Y intercepts. Let's talk about those. How do you do an X intercept? You set Y equal to 0. Y intercept, X equals 0. This one's easy. This one's hard. All right, symmetry. You don't really need that for graphing, so I'm going to cross it out. Domain and range, you need to be able to find it, but you don't need that for graph. Well, you do kind of need domain, right? Where do you need domain? You need that for vertical asymptotes, right? Continuity, definitely need that. Vertical asymptotes, that's that. Okay. Differentiability, Don't really need that. That just helps with continuity. Okay. Relative extrema, definitely need that. Concavity, definitely need that. Points of inflection, yes. Horizontal asymptotes, which do you remember how to do the horizontal asymptotes? That's the limit as x goes to negative infinity, and the limit as x goes to positive infinity. And then infinite limits at infinity, that's like your end behavior, is what that is. Okay? Oh, before I forget, memorization sheet, second derivative test. Second derivative test. Says if f prime of x equals 0, f double prime of x is negative, means that it is a max, relative max. F double prime of x positive means, can't give up, relative min. Okay? You might want to put an equals, F double prime equals a negative, equals a positive. There we go. All right. So guidelines, x-intercepts, y-intercepts, asymptotes, inflection points, relative, yeah. Okay, so it's basically, we're going to put it all together. Here we go. Analyze and sketch the complete graph. You got it. All right. 1. Factor. So f of x equals 2 x minus 3 x plus 3 over x minus 2 x plus 2. All right. If anything cancels, that equals holes. All right. So now we do, I mean, obviously I would do vertical asymptotes, they just fall right out. So I do vertical asymptotes and horizontal asymptotes. So vertical asymptotes are where you set the denominator equal to 0. So that's going to be x equals 2, x equals negative 2. So now I'm going to go over my graph, and I'm going to put vertical asymptote at 2, and at negative 2. Okay? All right, now I'm going to do horizontal asymptotes. Now, so you do the limit, and this is also end behavior. So that's like all together. So the limit as x goes to negative infinity. I prefer to look at this one of 2x squared minus 18 over x squared minus 4. It's the only time really that the factored one is nicer. And what do you get? Well, this all cancels and you just get that, so you get 2. Good to know. That's negative infinity. Also, the limit as x goes to positive infinity of 2x squared minus 18 over x squared minus 4 is also equal to 2. So that's nice. So it's going to go both ways, because sometimes you can just get a half one. Okay. Now, if you get a horizontal asymptote, all right, then you're going to want to know, does it cross it? Okay. So it says cross HA. So what you do is, well, what does it mean to cross it? It means that the function value is equal to that horizontal asymptote value. So I'm going to set 2x squared minus 18 over x squared minus 4 equal to 2. Okay? And again, it's useful. It's more useful to do it in its factored form. Okay, in its FOILed form, I mean. So now I'm going to cross multiply. So I get 2x squared minus 18 equals 2 times x squared minus 4. Cross out this 2 and take a 2 out of here. So x squared minus 9 equals x squared minus 4. Now my x squareds would cancel and I'd get negative 9 equals negative 4. Okay, and no. So no, it doesn't cross it, because that just came out to be nonsense. Okay. All right, so that's good to know. Now I'm going to find x-intercept. Actually, I'm going to do y-intercept because that one's easier. That's just x equals 0. So crosses HA, go back here. That's set f of x equal to your HA, or your OA. Okay. No, it's not really going to cross the oblique asymptote, so just do the HA ones. All right, and this is the limit as x goes to plus or minus infinity of f of x. Y-intercept is x equal to 0, right? So that would be f of 0 equals 2 times negative 9 over negative 4, which is negative 9 over, well, no, positive, sorry, negative over negative, and then 2 goes into 4 twice, and 2. So 2, 4, 6, 8, so 4.5. All right, and since I know you can't cross the vertical asymptote, and you can't cross the horizontal asymptote because it doesn't cross it, then this must look like this. But I'm going to plug in negative 1 to see where it crosses that. So plug in negative 1, and that's just like some helpful extra information. So that's 2 times negative 8 over negative 5. So that's 16 fifths, 5, 10, 15, and then one more, so 3 and a fifth. Is that right? Oh no, that's negative 3. Just kidding. I was like, that doesn't make any sense because it's going down and then I would cross it, but I already found that it doesn't cross it. Try that again. So it's 16 thirds. So 1, 2, 3, 4, 6, 9, 10, 12, 13, 14, 15. So 5 and a third. And that's probably going to be symmetric. I'm just going to guess that it is. Actually, I know it's going to be. Plug in 1, you still get the same values as negative 1. Okay, so see how symmetry doesn't really, I mean, you can just figure it out as you go. All right, and then over here, you can plug the points in and guess and check, but let's go ahead and do x-intercepts. Which means solving y equals 0. So that means 2x squared minus 9 over x squared minus 4 equals 0. which means that equals 0, so x equals plus or minus 3, because that can't equal 0, right? Okay, so we get plus or minus 3. So 1, 2, 3. Okay, now let's do -4. Let's just plug in f of -4. So that's going to be 2 times 16 minus 9. 9, 10, 11, 12, 13, 14, 15, 16 over 16 minus 4, 12. So that's 7, 6. So 1 and 1, 6. So it's going to look like that. And then I can just imagine what it looks like because I can't cross the horizontal lines into it because I already found that it doesn't do that. And then 4 is going to be the same thing. All right, I did not use any calculus except for the limits thing in this problem. I didn't need any concavity or any of that kind of stuff. All right, and that's it. And then I want you to try this one, and I'll upload the video on how to do that one.